Hello, this is Unit 2. This is Topic 1, Types of Chemical Bonds. Let's remember together what are the types of chemical bonds. You know that there are 100 million known chemical compounds and maybe more, but they are all held together by just 3 types of bonds. What are these bonds? I have only 3 types: the ionic bonds, the covalent bonds, the metallic bonds. Ionic bonds are the drama queens. Complete electron transfer. The electron move from one to one, the sodium to the chloride. The sodium loses an electron, chloride gains an electron. Once the electron moves, this become positive ion and this become negative ion, and these charged ions become electrostatically attract. So the bond strengths depend on the charge. If it is +1, it's a weak charge. If it is +2, it's stronger. If it's +3, it's stronger. And the stronger the charge is, the more the attraction between them. And that's what we call the lattice energy. The lattice energy is stronger. Bond strengths depend on the charge, not only the charge, the size. So according to Coulomb's law, the bigger the size is, the less the attraction is. If the ion size, like sodium and chloride, are small, the attraction is stronger. What about covalent bonds? Here there are sharing of electrons between 2 atoms. Maybe the same atoms like hydrogen in hydrogen molecule, or different like H and Cl in the hydrogen chloride molecule. So they try to achieve the stable electron configuration of the next noble gas. It can be polar or it can be nonpolar. It depends if the sharing of the electrons between them is equal sharing or unequal sharing. Let's have a look at the metallic bonds. These are the surfers riding the electron sea. So the metal cations in a sea of delocalized electrons. Electrons are mobile. This explains why they are conducting electricity, why they are malleable and ductile. Can you answer the quiz? Which type involves a sea of electrons? Yes, it is the metallic bond. Very good. The second is the electronegativity challenge. If you have a covalent bond, electrons are shared between 2 atoms. Some of the atoms will try to attract the electron to itself more than the other atom. This is called the electronegativity. The higher the electronegativity of the atom, the more it will be able to attract the electron to itself. Remember that as you go to the right, the electronegativity increases, and as you go down the periodic table, it decreases. The biggest one with the highest electronegativity is the fluorine. It has a number of 4. The difference between the electronegativity of different atoms, like hydrogen, chlorine, makes it a very easy way to predict the difference between them in the electronegativity, and so you can predict the type of atom. Usually we say that if the difference is 1.7 or more, you can have an ionic bond. The attraction is so much that one of them took the electron to itself. If it is less than that, it will be a polar covalent bond where the electrons are shared between 2 atoms but not equally. And if it is less than 0.4, you will have something called a nonpolar covalent bond where the electrons are shared equally between 2 atoms in the covalent bond. Remember, the ionic bond, we said the electron is transferred from one to another, and the electron is lost from the sodium and gained by the chlorine. This forms the attraction between them. One is positive, one is negative. Electrostatic attraction causes them to attract and leave together in the ionic bond. So what happens to sodium in the sodium chloride? Does it gain an electron, lose electron, share electron, or nothing happens? Of course, the sodium loses an electron. Covalent bonding can be done easily. So if you want to get one oxygen atom, put it beside 2 hydrogen atoms, then voila, you did the water molecule. That's it. Remember, it can be a single bond if 2 electrons are shared between the atoms, like in hydrogen. It can be a double bond. Here I have 4 electrons or 2 covalent bonds. Remember that the bond length is almost 74, and this is the bond energy 436. If you have double bond, it will be stronger. It's a shorter bond. Remember, shorter bond and stronger bond. The bond energy is almost 498. The triple bond like that between the nitrogen is a triple covalent bond, and this is very strong. It's the shortest and strongest. The strongest, it's 946 kilojoule. That was 498, and the single was 436. So the more bonds you have between the atoms, the stronger the bond is, more difficult it is to break, and it is shorter bond. In the metallic bond, if you remember, there are C of electrons. So the electron of each atom is not linked to its atom or revolving around it. It's moving between the different atoms. That's why this explains its conductivity. Why can metals conduct electricity? Because they have ionic bonds, they have mobile electrons that can move freely. This is the answer. They are also having three properties: conductivity, the electrons flow freely through the metal lattice; the malleability, layers can slide past each other without breaking bonds; luster. Why is metal having this lustrous appearance? Because the mobile electrons interact with the light waves. So a single copper wire contains about 10 to the power of 23 free electrons. That's more than all the stars in the universe. So Lewis structure workshop. We'll have a separate video to explain the Lewis structure carefully, but as a fast review, let's have a look. First, have to count the valence electrons. So if you have H2O, what do? You count the valence electrons. The hydrogen has valence electron 1. There are 2 atoms, so the total is 2. Oxygen is in group 6, so it has 6 electrons. You will know the number of valence electrons from the group number. Oxygen is in group 6, so it has 6 electrons. 1 atom is there, so 6 plus 2. You have a total of 8 electrons. The second step is to find the central atom. Which atom is in the center and which is peripheral? Central atom is oxygen. The hydrogen cannot be central. You have one atom only of oxygen and 2 hydrogens. So it's impossible for the hydrogen to be in the middle. Oxygen has to be the central and 2 hydrogens on the sides. The next step is to draw single bonds at least between them. So draw a single bond between this hydrogen and oxygen and single bond between this hydrogen and oxygen. Now at least you have one bond. Bond is made from 2 electrons, if you remember. I have used out of my 8 electrons 4 electrons, so I have 4 more. Where do I put them? I have to put them as lone pairs. This is step number 4. So I'll put 4 electrons, 2 lone pairs and 2 lone pairs. So I have to make sure that everything is octet. So except for the hydrogen, all atoms should be having 8 electrons around it. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This is the perfect Lewis structure. For the hydrogen, it's a DeWitt rule, so it can have only 2 electrons around it to be like the next noble gas, which is the helium. Now I've made all the steps and get the perfect water molecule as a Lewis diagram. How many valence electrons does the oxygen have? Remember, it is 6. Again, I'm saying that we will have a separate video for the resonance and the all structures of the Lewis diagram to make them perfectly. The formal charge detective. What is the formal charge? This is very important concept that comes always in the AP Chemistry exams and most high school exams. Formal charge helps us determine the most stable Lewis structure. So sometimes a compound have 3 or 2 structures that are all possible structures. How I will know which one is, so this is possible, this is possible, this is possible. If you want to know which one is the most stable one, you have to look at the formal charges of the atoms. Think of it as if I split all the shared electrons equally, how many electrons would each atom own compared to its neutral state? The formal charge calculator can be done by finding the valency electron and subtracted from the lone pair of electrons and then subtracted from the bonding electrons. If I have, for example, a molecule of water and you need to know the formal charge of the oxygen atom, remember that it has 4 lone pair electrons and it has 2 bond pair with the hydrogen. So the oxygen has a valency of 6 because it's in group 6. And if you subtract the lone pair of lone pair electrons, they are 4. So that's 4. And then how many bonding pairs? It has 4 electrons in lone pairs and it has 4 electrons in bonding pairs. But you have to divide this by 2. So this means 4 divided by 2. If you did like that, 6 minus 4 is 2. And this is practically 2. So 6 minus 4 minus 2. This means that it is equal to what? So don't forget that this has to be divided by 2. So I get a result as 0. So 6 is the valence electrons you get from the group number. Number of lone pair around it, it's 4. Number of bond pair are 4, but divide this by 2, so it becomes 2. So 6 minus 4 minus 2 is equal to 0. This is the formal charge of the atom if he asked you about. The intermolecular forces. I have three types of intermolecular forces. Don't worry, I will explain every one of them perfectly. The intermolecular forces is the forces of attraction between molecules, not between atoms. I can have a type called London dispersion forces. This is temporary forces, but they are the weakest. It's universal. What does it mean universal? It's available in all types of molecules. The dipole-dipole are stronger than the London dispersion forces. It's because polar molecules attract. So if you put two polar molecules beside each other, HCl and HCl, they will attract each other. How can I identify? The molecules must be polar. They have permanent dipoles like HCl, SO2, H2S. And we said that they are stronger than the London dispersion forces. The partial positive of this molecule attracts the partial negative, and the partial negative here attracts the partial positive. If the molecule has a dipole-dipole and one of its atoms is hydrogen, link it to a nitrogen or oxygen or fluorine, this is the hydrogen bonding type and it is the strongest one. Again, don't be afraid. I'm going to explain this perfectly in the intermolecular forces video that's made only for that. The London dispersion forces are the weakest one. It's present in all molecules, even in the noble gases. Remember this. Only intermolecular forces in nonpolar molecules are London dispersion. So the strength increases with the increase of the number of electrons or the molecular size and is caused by temporary electron movement. So let's try to know the properties of each type of the bonding: ionic bonds, covalent bonds, and metallic bonds. Which one of brittle? Ionic bonds are brittle. Which one is malleable? The metallic bonds are malleable. Which is usually insulator, does not conduct electricity? The covalent bonds. Which are usually good conductors? The metallic bonds. Which is having high melting point? Is it the ionic bond or the metallic bond? The ionic bond have very high melting points and often water soluble. This is also the ionic bond. So this is the correct answer. Thank you so much. That was like a small summary of 2.1. Unit 2.1 has too many details and many examples. That's why we'll be specifying a specific video for each of the topics so that you can practice it very well. And I will be leaving also the link for the slides that we are using now so you can play with it a little before you see the next video. And thank you.